Hey everyone, today we're going to do a precedent tutorial. This one's going to be a bit different from others because this one is going to be one precedent, three different methods. And this is to show that there are multiple ways to do different things with similar results. Some have advantages and disadvantages in certain areas of it. So I'm going to get started with that. All right, so I'll pull up a picture real quick. I have this up on my other screen. Also, sorry, the dimensions are a bit off for YouTube. It's just this is the only screen I have right now, and I'm using this. What's it called? I'm using this screen to record. I could use the other screen, but I'm having a bit of trouble with that one. So I apologize for the resolution, and I hope you guys can still see it. I did already a test recording, and it looked fine. It's not gonna look pretty, but it's gonna be tolerable. So I apologize for that though up front. So I'm going to get a different screen monitor that will have a 16:9 ratio at least. So it'll be pretty easy to, what's it called? Manipulate. So anyways, as I was saying, let's get started. So let me just change this. Sorry, one second. Okay, so let's get started. Just making sure I can see my OBS. Excuse me. So first thing we're going to do is we're going to do the form for it. As you can see, I don't even have the form done. So I'm going to do that real quick. So I'm going to make the form in Rhino, at least the kind of curvature. So I'm going to just kind of make it the profile of it. Let's say something like that. And then what I'm going to do, since I have that, I'm going to rotate it. Move that up. Then I'm going to copy different times, so through 4 different times. I'm going to rotate this one this way, rotate this one here, and these are going to be our control curves. And then I'm going to rotate this one 180. There we go. And what I like about using curves to generate the surface rather than anything, rather than just making it a different way, or at least in this method, is you can start to take the, like if I, for example, if I lofted this together right now, I just say a closed loft, you're going to get something like this, right? And then I hit OK, and then we're good. But the problem is, once if I want to change this, I actually don't like this shape at all. I think it should be a little bit bigger anyways. But so if I did something like that, but either way, I don't like overall this. So to customize it, I'm going to make a curve node here and do select multiple curves and select them in a very particular order, just in kind of a circle like that. Hit enter, and then I'm going to loft them. So I'm going to loft them in Grasshopper. So I can do something along the lines of this, and then I have to do loft options in order to close it. And then just change this toggle to true. Oh, let me move my mic. So hope you guys can hear pretty well. One second. So what I'm going to do now is, I see this now. And now the reason why I did it in Grasshopper instead of Rhino, unless you know exactly what you want, is you can start to change it around and actually look at the results without having to keep deleting and relofting. So I'm going to actually move this in, make it a little bit different. I'm going to move this down here like that. Make it really different than the Beijing one, but this is in principle how they did it too. We can also scale this one up a bit more. Just get this little weird bulge here. That's a weird word. So I can do this, then move this up, and then move this up here. So I get something like that. So I get some kind of wonky geometry forming out of it, which is what I want. So now that I have that, what we're going to do is we're going to create a sphere in the center of this. So I typed in my sphere, but as you can see, if I just plug this into the base, nothing really happens. So what we're going to do is we're going to create a center point for it. So we're going to actually find the center of this. So we're going to do area, and we're going to get the center of it right here. So no matter where I move it, it's going to always capture that center. I don't know where it's at now, But anyways, so if I put my sphere into the centroid, see, it's pretty small, but it will always be located there. Now, so if I take that, I want to make the radius, so you can guess the radius. So if I do like 200 or something, it's going to be ridiculously huge. Oh, something like that. So actually, I probably want this done a little bigger. So let's say that. So you could do this, or another way you can do this is actually using the parameters of this loft. So what I'm going to do is actually just do a quick bounding box. And I'm actually going to do a bounding box of this. And as you can see, the results of this just says box. So all I have to do, so like if I plug in a panel, you're going to get just box, which isn't helpful. So what you're going to do is deconstruct box. Right here. There we go. So these. And then you see there's an X and Y dimension. I don't really care about the Z dimension because it's a sphere, so it's going to equally kind of give the radius out in all directions. So that's a very varying way of changing the dimensions. Because if the XY is obviously, XY dimensions are obviously bigger than the Z direction. You can just tell based off the numbers here, 91 plus 180 versus 200 plus 300. I mean, it's just obvious. So just based off the numbers. So basing off of that purely, what we can do now, if we look at it as a panel here, we have 325 to 218, which is, I would say, like, that's a big distance. But this doesn't help us out. This is a domain. Whenever you see something to something or a number to another number, that's a domain. So what we need to do is actually, I want the number. I want the actual total length of it, a scalar value. So I'm going to do a deconstruct domain. And now this will give me, as you can see, the numbers 325 and 218. So you're like, oh, cool. Let's just add those two together and we get the length, right? Well, you're going to get a number lower than we have. You're going to negative 106. You're going to be like, huh, that doesn't sound right. Like those don't sound right? Because remember, this value is negative because this is in the negative direction, as you can see. So it starts from, because it's starting from coordinates. So it's starting from negative 325 to 218 right here. So plus 218, negative 325. This is the x direction. Yep, okay. So what you need to do is, if you remember some basic math, a negative times a negative is a positive. So you just need to make that number positive so it adds correctly. So just type in negative, and this will change that value into a quote-unquote negative. So it'll add a negative value to it, but really it's already negative, so negative times negative is a positive. All this value is doing is multiplying this by negative 1, excuse me. You can also do like a multiplication as well if you really want to, and then do that. Or you could do expression if you want to go super complicated, but I don't see why you need to do expression for a negative times a negative, but yep. So if I add that, I get 543, which sounds right. And basically we're going to do that with the same value of here as well. So we're going to have that. So 543 by 592. So you're like, all right, cool. Now we have this. So why did we get this again? Like, it doesn't make sense. So what I'm going to do, since a sphere only needs one value, which is the radius, I'm going to pick one of these values. And you're going to be like, which value do I pick? There's just two of them, right? So I'm going to pick the larger value because the larger value is going to actually encompass this entire thing, right? So let's do that. So we're going to put in the base, which we have here, and then we're going to delete this 200. And we're going to put in the radius into here. And you're like, whoa, that doesn't look right, right? It's expanding. But you remember, we're plugging into the radius. This is the total length. So it's doing a diameter. So you need to do a division, right? So if you want the exact number, you divide it by 2. And let's turn off these values. And as you can see, it's encompassing it exactly. But remember, this is a flexible object in terms of like there's going to be some sticking out. So you need to account for that basically. So if we do this, if we divide it by 1, we're going to get the same number, 592. So let's turn this into a 1 to 2 proportion. So we know that 2 is too close and 1 is too big. So we can do, actually, the minimum being 1 and the maximum being 2. And change this to a rational floating number. And now we can actually start to play around with that. So we know 2 is too small. Then we can actually just kind of gauge based off of this. So we can do like a ratio of 1.8. Seems pretty good. So as long as it encompasses the entire thing, which is good. Sweet. So we have that, which is exactly what we needed. All right. So once we have this sphere, we can now, and the reason why I did this, so as you can see, this looks a little complicated. Like, you're probably wondering why I did this in general. So you're looking at it and you're like, okay, so like, let's say if I move this around, we already showed why I move it around. I mean, it's good. But let's say if I want to change the size, that's always going to encompass at that range, no matter what I do. If I rotate it or whatnot, it's always going to remain that, no matter what I do, which is one of the most powerful parts about Grasshopper, in my opinion. So it's less work in terms of the long run. So if I'm making iterations off of this, I don't need to, let's say, change that number slider from 200 constantly every single time, and it won't freak out my script, because this is just a good way of making a clean script. I can also just delete this. I'm just going to keep this as scrap work. Now, if I was optimizing the script, yes, I would delete this. There's 0 point in having this, but for the sake of education and teaching you guys, I think it's important to have that. So I'm going to keep it on there. So this is 900 for some reason. 827. What the hell? Oh, because I changed the radius. I was like wondering why the values got bigger. So anyways. So now what we're going to do is do a populate 3D. So we're going to populate this sphere with some points. And then remember, we have that area. So we're going to create a vector between this point and the center. So vector 2 point. And then, so this value, and this value. So as you can see, it's creating that vector here. It's creating around 100. So now you just need to create a, what was it? Plane normal? So you need to create a plane normal. So literally what you're going to do is asking for a origin and the z-axis. So the origin is going to be our area. And the z-axis is going to be whatever this vector is. So it's hard to see, but there's just a ball, literally, of planes. Very hard to see, but it's there. It's glowing, literally. It looks like that. And I'll show you guys a different illustration of how to do this as well. So there's 2 ways to do this. So this is one way right here. And then we're going to, after we do that plane normal, we're going to create, I'll explain why this plane normal stuff works after I'm done. But we're going to do the plane normal, and then we're going to do a brep plane. So the brep will be whatever we're using to, whatever we're trying to slice. So this will literally create the random lines that we get from the bird's nest. So let's do that. We're going to plug in the brep into the loft. And the planes are obviously this. As you can see, we're creating this nice kind of geometry right here. Looks pretty, actually. So, and you're wondering, all right, and so I'm going to add some number sliders. I'm going to add 100. And I probably want to lower the count. It looks a little high. I'm going to... Doesn't even be that many. Yeah, something like that. Anyways, something like that. So, that looks pretty good. And let me hide this sphere. So you're wondering, how did that even happen? How did it just went from a plane to lines? Like, how'd you get geometry out of that? That makes, or curvature out of that? Makes no sense. Well, you look at the node, brep plane solves intersection events for a brep and a plane, otherwise known as section. So if you just look at the image too of the icon, you can see a plane is slicing that cylinder. Basically, we just made a bunch of planes. And remember, planes are infinite. If I make an XY plane here, it's infinite in terms of the XY direction. All a plane is, it's just showing direction, just like a vector. It's showing a direction and how to kind of manipulate this object. Same with vector, obviously. But all that plane is doing is that. And with that plane, since it's infinite, we're just trying to say how it's basically, this is calculating how it intersects and it's creating curvature based off of that. Now, if that doesn't make sense, we're going to do the second way of doing it, of doing this exact same result with a different method. So literally what you can do is, now that you have the plane normal here, so what we can do is just do a rectangle. And now you have this and this. Then you're going to put a plane into here. Now this is obviously a lot more work than this, but this is another way of doing it. So you see this ball of stuff. So you're going to have to do a construct domain. And then we need to add a negative here. XY size. Yep, okay, this is right. Add a negative here as well. And then we're going to add just a value of 12 for right now. We can always change this, obviously, but just right now we're just adding 12. Wow, on this. See, these rectangles are getting a lot bigger. And let me change this value to like 1,000 or something. All right, so if we look at that, you're like, whoa, what's it doing? Like, that looks cool, but like, it doesn't make sense, right? So basically you just made the rectangles a large size. And we're gonna make this a surface now. So we're gonna do a boundary surface. And we have this slice and dicing happening. It's like, oh, but if you look carefully, like if we click this BREP curve, you can see that's exactly top view. Let me see in top view if it's a little easier. No, top view is a little hard to see. But you can see, it's hard to see, but the planes are actually intersecting exactly there. Now this plane, BREP plane component, just calculates those planes as infinite geometry and actually shows that intersection. Now with this, we can do the same thing. We can do a BREP. Is it BREP? I can't remember. It should be under intersect. Sorry, I'm having a blank. It should just be BREP. You could do BREP line, I think, but yeah, BREP. Okay, it wasn't showing up. So if we take this BREP, which is surface, and the other BREP, which is that loft, let's see what the results are. I bet you it's the exact same. This, well, it's not. Okay, hold on one sec. Okay, yep, and that. Oh, I know why. My rectangle is not large enough. Okay, there you go. Oh, this curve is in the way. Let me hide this. But yep, it's the exact same, as you can see. Now this is a bit different because if I do change the size of this, it won't correspond. But this was just a visual, just so you guys understand of what this component is doing. So you can do it this way if this makes more sense. Like, I mean, do it. I don't see why not. Let me hide this too. This is bothering me. Okay, so so you have this. Cool. So now we have these curves. We can hide this. But now that we have these curves, we need to actually turn them into geometry. So we need to basically turn these into open image new tab. Okay. So we need to basically, as you can see, almost looks like those kind of pipes are blanketed on there. So let's do that. So first we're going to create this to have some thickness. So we're going to do a quick offset curve on surface. So we're going to take this curve with a distance of, let's say, 0.25, just as an example. I'm not too sure exactly. And then the surface, which is what we need. So I'm actually going to type in surface in here. I'm going to plug this in here. And I'm going to grab that loft from all the way back here because I hate going back all the way there. So as you can see, it's offsetting that 1/4 of an inch. Let's just do larger. So right now it's calculating all those kind of curvatures. All right, and now we have that. So I want to act this as the center line. So if I do scribble, if I do center line, so if these act as the center line here, we need to basically offset the other side, right? So we get that, that's the center. So we can do a flip curve. So we're basically flipping the direction of the curve in order to offset. So instead of offsetting this way, it's going to offset the other way. So curve, distance, surface. And let's flip this back. It's always good to kind of keep your things in order. So now we have this, right? So we now need to weave them together and actually create a surface out of them. So if we weave them together, like I just said, it'll be this one and this one. And now if we look at the list, we want all these kind of lines to read individually. We want them to read them as one. And it looks like it's already grafted. So we want to make sure it's grafted. And it looks like one says a line like closed curve. What the heck? What's closed about any of these? Guess that? Maybe? I don't know. Anyways, let's try it. We can do a loft. As you can see, it's creating those surfaces for all of those. Or you can do also this, or a ruled surface, and plug these into here. Basically, it's the same thing. Or you could do an edge surface. As long as these are grafted, as you can see, that's why I checked. So I'm going to display it on here just to show you guys. But as long as... Did I freak it out? This should be the same. Okay, yeah. As long as these are grafted, these will all give the same result. Maybe one's slightly more accurate than the other, but I'm going to go with... So this edge surface, it's not making that one. Oh, there's the closed curve. That's what I was wondering about. I was like, why is this closed curve? All right, well, that's weird. Anyways, we have this ruled surface. So now we need to add thickness to it. I'm probably going to, so this edge surface doesn't work for this one in particular because I think it's a closed curve and it does not understand. Yeah, it's closed. It doesn't understand that. So I can use either the loft. So one thing you can do with the loft options too is kind of find a rebuild, refit. So you can do a 0.01 and try this, refit with this kind of tolerance. So we can get the tolerances nice. We can also turn up the quality so we can see a bit better. 0 equals no rebuild. Just so we can actually start to see these loft types, normal, two types. So let's do a tight loft. Okay, it looks pretty good though from here. But anyways, so once we have that loft, we need to add the thicknesses here. So you can see there's actual thickness here. So let's do that. So what I'm going to do here now is do a brep wireframe. As you can see, we have that. Then once we have that, we can offset that. We can offset this. Hold on, let me think. Okay, so I would offset that. Just drawing a blank right now. I mean, I guess you could do... Another way I'm thinking of doing this is you could scale. So if this was 100% of the scale, I would do like 1.1. But this wouldn't be an exact way, I feel. Where's the area here? Probably should actually. So I have to bump up this tolerance a little bit. 1.02. So that doesn't seem to work. Okay, I think offset surface. Oh, it's offsetting the other way. Okay, so you're gonna have to do a negative. So I would just throw in a negative here. So what I'm gonna do is an offset surface here. So it's a little bit of troubleshooting I had to do. Again, I'm not perfect. I forget. I have to do my own troubleshooting. So as you can see, I offsetted it here to here. And then we're going to do the B-rep wireframe of this. Then what we're going to do is take these curves actually, no, what we're going to do is do a B-rep wireframe of the others. So we're going to do a weave again here. Plug this in here, plug this in here. And then we're going to do a loft here. Well, that ain't good. Oh, I think I know why. All right, I know what's happening. Oh, after it crashes, I'll figure it out. Of course. Of course I have to crash the computer in order to figure it out. Isn't that crazy? All right. Yeah, right here. So you see it's partitioned in some way. So what I'm gonna have to do is I actually have to graph the data. So what I'm gonna do actually this is a tip I usually do myself, or a kind of pro tip I do. Not pro, but I do know something, I guess. I don't. I'm gonna list. I'm going to look at this first. I'm going to first. I'm going to flatten both of these. So let me find whatever I highlighted. Am I not getting anything? Line like curve, yeah, find it. It's not showing up. Where is it? What? Data's going in. So what I was gonna do is I was gonna actually weave it here with just these two curves. Oh, it's this tiny, tiny curve. I was like, what? Okay, so that's working. So it's creating that kind of box-like structure. Okay, so it is working. So if I do this, let me think. I think it could also be my direction of these curves, maybe. Yeah, this is fine. It's not... Yeah, it's creating the geometry I need. This should be the exact same thing. Maybe it's something I'm doing wrong. No, it seems right. It shouldn't be like crossing streams. It shouldn't cross space and time just to connect. 292, 584. Huh. That's curves though. That makes sense. This is weird. Like it works perfectly fine here, as you can see. Yeah, it's not partitioned here, but I mean, it's the same thing if I graph them all and then put them in two different lists. It's the same thing. I'm trying to think, like, what did I do wrong here? Did this change something? Let me try ruled surface, because this doesn't make sense. I mean, if I graph these, nothing's gonna happen. Yeah, it does the same thing. That makes no sense. Why is it doing this? Do I have to flip the curve back or something? Did I do something wrong with that? That's all I can think of, the only other solution I can think of. Well, that's not it. Does this process the data any differently? No. This keeps the data structure. I can't think what I do wrong. This makes no sense. Like, this works fine. It's the exact same thing as grafting it. I'm just lost right now. I don't understand why it's not working. If I do the same thing with this ruled surface, I'm going to get the same result, right? I mean, it should be the same. I mean, I guess I could just do that and like offset this, but I mean, it's just gonna be the same thing. Well, I mean, hold on. Hold on one sec. So what I'm thinking, I already have these curves. So, well, I don't have that edge and that edge. So maybe that was wireframe. So maybe the loft was necessary to do this. Yeah, I mean, would I just offset the curve? Like, what's that gonna do wrong? Well, let's see. If I do this, if I do brep wireframe, oh, well, I already did that. I'm dumb. Okay, and then weave, and then loft. Yeah, it's the same. What's it say here? Loft can only be done with. Oh, I have a closed curve. That's probably why. Okay. It's gonna redo all that geometry. Do I have any closed curves? I don't know why I even have a closed curve. Like, why? You can see this one's just spanning across the entire thing. This one's looping like a nunchuck all across. Huh. To go back to my geometry here. Well, if it'll load. Well, my computer is being a bit funny right now. Like, why is it doing this? Why is it circling this? It doesn't make any sense. Is there a rectangle that's really doing that? I guess if I made the sphere a tiny bit bigger. Like 1.5? I don't think that changed though. Like, if you change that to 1.5. Oh, my sphere is visible now. Okay. Yeah, there's one that just spans all the way across. I don't think that should make a difference though with that. I just don't understand why that doesn't work still. Even if it is closed, it doesn't matter. Yeah, it doesn't matter. I just... Like... Like, that should work. I don't understand. I think because I know I kind of can see why, but it also just doesn't make sense. I don't understand. It doesn't really make much sense. Wow, this was a eventful video. I can't even figure it out. Let's just change the seeds, see if it does anything. I'm gonna see if I can change the optimization of it. Well, if it'll load, I don't know why it's taking so long. I mean, I know why it's taking so long, but still. There we go. All right, now I can start to do some troubleshooting on this. Yeah, there's one that just spans all the... Oh. Should be false for like all of them, except for like, yeah, this one. Yeah, number 14. So what I'm gonna do here is move all this stuff because it's still useful, and take this data and eliminate that one list here. Let me think. How do I... Well, I know it's number 14 anyways, so I can just... Number 14. Number 28. Oh, maybe it's 28. I'm seeing anyone else's. No. So you can just look at the list. I'm going to do 20, 0 through 28. So should be... I want to make sure it's that one I got. Yep, okay, so that's the true one. So I can do sweet. So I can do that. Sucks I have to do this. Oh, wrong one. Oh, I have to flatten this. There we go. Should be that one that spans across is gone. Okay. Yep. So I can type in curve here, and I can plug these two into here, and I'm plugging into here. So all I have to do is literally disconnect this if I don't want that again. That's what I would do. Okay, cool. So I'm going to do here. Okay, so what I'm going to do is loft. I mean, I should be able to just plug that in here. Well, it's not as well, is it? Why am I have? Okay. So this sometimes happens when you loft, it'll create a B-rep. So if you keep it as a ruled surface, it'll always output a surface, while this outputs a loft, which could be a surface or a surface or a B-rep. I don't know why outputs a brep sometimes, but sometimes it does. It just depends on the script. Like, seriously. I've done this before, so I've never ran into this problem, but hey. I'll explain after I get this to work how I attempted, or how my brain was working on this, because let's just see. Let me do show. Okay. Zoom. Okay. Okay. I know it's the wrong direction, I believe. Yeah, it's the wrong direction, but I'm going to loft it anyways to see if it works. All right, so it does work, but we need it to offset the other way. There's just one right here. I see why it's kind of glitching out. I mean, I think also my geometry may be a little weird, so let me change that. Okay. That's weird. My geometry definitely played a role in that. Okay. Sorry, I've been a little flustered this video. It just ran into like half the problems I've never ran into before. So, but what I'm going to do is I'm going to do a preview. And I'm just going to plug this in right here so we can just look at it real quick. I'm going to hide this. Actually, what I'm going to do, even better, I'm going to take this, bake, and I'm also going to bake the, is this shaded view? I'm also going to bake the loft. Oh, I was wondering, something's not right. That doesn't look right. I forgot to bake the, when I offsetted the surface, I forgot to bake that, and then bake the ruled surface. Okay, yep, okay, that's fine. So I can highlight this whole thing and type in join. So unable to join curves, that's fine. Those are I know what it's talking about. Show. And now you have your precedent. Wow, it's been 48 minutes of me figuring that out. Well, not the whole time. It was 48 minutes of other stuff, but so as you can see, it's literally wrapping around this kind of geometry here. But yeah, that's pretty much it for this, at least. So as you can see, if I do show edges, no non-naked edges, no manifold, 1, 2, 3, 4. Wow, coincidental. So if I go to rendered view, you get this. Oh, that looks nice. So you're gonna get something like this. Also, you can now delete or cell curve lock, cell all, then delete. And then now, what you can do that I really like about Grasshopper is you can do Grasshopper here. You're going to get all this. So once you have that, you're going to have to kind of group everything together. So you can just do a quick merge. So remember those lofts that I had, kind of grab them. The order doesn't matter because remember, we are just grabbing geometry here. We're just literally grabbing the geometry as for visual purposes and nothing else. Offset the surface and the rolled surface. Should just be 3 things. Yep. So you have this. and then we can do a custom preview. And then we can change that material. With manage shader. I feel like, is this it? Yeah. Okay. So you can actually hide everything. So and I can actually do this. Graphed. Alright, there you go. So as you can see, it's rendering that geometry. I can do the manage shader collection and hit OK. And I'm also going to do that again. Plum. Get rid of that. I want plum. Diffuse is white. I want it to stand out, so I'm going to add a gray. Well, not that much, but anyways, so you're going to have that. So one thing you can do is you can kind of see it rendered almost, and we can kind of start to guess what this will look like if we try to now move these parameters. Oh, it's locked. So once it's rendered, you can kind of start to just push these in and watch it kind of do its magic. Probably do this in shaded view still, so it renders a little bit faster. But yeah, you can start to kind of really push that in, and then this is where Grasshopper is really powerful, where you can actually start to manipulate certain parts of the geometry and actually start to deform it and the way you want to, and actually see the results live almost. So yeah. That's pretty much it for this tutorial. That's the bird's nest. That's one way to kind of create these swooping edges and things like that. But yeah, guys, I hope you guys enjoyed that. Yeah, that was a bit of a roller coaster. I'm surprised I got it, honestly. I was about to just give up, but yeah, you shouldn't give up. But yeah, so sometimes the geometry does matter in this. So, but yeah, that's pretty much it for this, guys. Thank you guys for watching. Hope you guys have a great day, and I will see you guys on the next iteration of this. Thank you very much, and I'll see you guys later. Have a good day. Bye-bye.